Okay, so with your page 46, right, I've already messed that up twice to make sure I'm right. Page 46, with it turned sideways, this is your red line right here. I want you to write skiing the slopes. And then you are going to draw that picture really big, but make sure there's some room over here to the side. You can like take up the whole piece of paper. It doesn't have to be like identical to mine. If it was that important that it was exactly the same size and everything, then I would have given it, I would have copied it for you. But, oh, sorry. Just want to make sure you know how to spell skiing. Okay. So everybody got the skiing the slopes part? Yes, page 46. All right, so then this is what you're going to draw. Large, take up pretty much the whole piece of paper. Just get that general shape there. So this is a corny little thing on slope that I like to do. You wouldn't need about half of it, probably. Most of you don't. But there is something beneficial to what we are doing here that will actually help everyone. So I just want to make sure that we're not getting anything wrong with slope anymore. Right? So first, we're skiing the slope. So we are skiing like water skiing. Not water skiing. No, that makes no sense. We are snow skiing. Thank you. We are snow skiing because you can't water ski slopes. That makes no sense. We're skiing the slopes, right? So some of you may have never been snow skiing. You may have never really seen real snow before. That's all good. I'm sure you've probably seen it on TV. I don't need your comments. Thank you very much. So when you ski, right, you got to have all the gear and everything. We're going to ski up this slope. So here's our little stick figure person. Okay. So here's his skis. Here's his little ski poles. All right. Yes, you have to draw him. And then here's his little ski hat with the poof on it. Okay. And if you spend all this money, because if you've never been skiing before, it's going to cost you more money than other people because you got to buy all the gear and all the warm layering clothes that most of us don't own. And you get there and you're having to like ski up a steep hill like this. Is this why you spent all this money? No, probably not. Like you're probably not having a whole lot of fun at this point. You're probably having to go uphill because your stupid friend fell and you got to go up there and help him, right? Like, come on, dude, how hard is this? All right, so we're not real happy right here. We're like, ugh, this is just terrible. So here's this little thought bubble, and this is poor me. That's what he's thinking. Poor me. Okay? The P, the reason it's poor me starts with a P because this slope is what kind of slope? Positive. So this is a positive slope. So if you are skiing uphill, if you got a line, think about your little skier. If he's skiing uphill, he's saying poor me, and it's a positive slope. Make sense? It's corny. Usually when it's corny, you can remember things a little bit better. All right, so then we get to the top of the hill. Maybe we didn't have to climb all the way up there. Maybe we actually got to take the ski lift. Then we're coming back down the other side. Now, you probably have to have at least some skill level to go on something this steep, but there's a little poof on top there. Now, is this kind of more why you went skiing? Yes. Okay, so we're happy at this point. We can say nice. Okay, that's great. All right, so nice, right? Why do you think this says nice? Negative, because this is a negative slope. So then you get down to the bottom. Now you're either like heading back to the ski lift, you're heading back to the lodge, or who knows where you're going, but there's no you're not skiing up or downhill at this point. Now, this isn't nearly as torturous as going uphill, but it's not really as fun as going downhill. You still may have fun on this because there is something called cross-country skiing. Like there's cross-country running. Some people actually enjoy that. I don't get it. Okay, if that's you, good for you. But I'm not running unless somebody's chasing me, and they probably have to also have a weapon, or I still may not bother. Okay, so but if you enjoy cross-country running, good for you. I kind of wish I did. I'd be in better shape. So there's also cross-country skiing, but we're going to pretend like this isn't really cross-country skiing, or maybe I'm having to cross-country ski, so I'm really not having any fun. So it's not that fun. It's like, but it's not as sad. So here, though, I'm having 0 fun. Because what kind of slope is this? 0 slope. Okay, does that make sense? Okay, so I'm skiing along. I'm not paying attention. Or whoever this little guy is, he's not paying attention because he's not having any fun. He's like, ugh, this is not fun at all. So he makes it to the edge here, and there isn't an edge, right? Okay. Okay, no stick figures were harmed in the making of this. Right? And don't forget his hat. Most important part. Okay. All right, so this happens, right? Because falls off. So he says, oh no. Right? Because there's 2 different ways to talk about this slope, right? What's one of them? Why is it a no there? Talk about it as no slope, right? No slope, or what's another way to say it? Undefined. It's no slope or undefined. No slope and 0 slope are 2 completely different things, right? If we're talking about your bank account and you've got no money, right? What's your balance? 0. So 0 money and no money, same thing. And I feel you, all right? 0 slope and no slope, 2 completely different things. Because right here, I have a slope that I can actually ski on. It's just a 0 slope, right? Here, there's not one there at all. It just doesn't even exist. That's why it's undefined. Okay, so you see the difference there? All right, so no slope or undefined. Undefined is really the better way to say it, but just I don't want you thinking no slope and 0 are the same thing because they absolutely are not. There is a value to this slope, and it is 0. 0 is a legitimate value. Okay, everybody okay with that? All right, so next thing, and underneath there, because you should have like space down here, we're going to draw an X and Y axis. And if I draw a line that looks like this, is that an X equals line or a Y equals line? Y equals, okay? So we could say that this is like Y equals 5. So if I draw this blue line, is that X equals or Y equals? X equals. So we could say this is like X equals -2. I think one reason why you get those mixed up is because you're trying to make them the same as the axis. The x-axis is horizontal. The y-axis is vertical. But a y equals line is horizontal and an x equals line is vertical. Because what this is saying is for every single point that you plot on here, every single one of these has a y value of 5 because that's where it crosses the y-axis. Every single point on here has an x value of -2. And there was, I think, one person on the algebra test at the beginning of the year that actually plotted about 6 points before they drew these lines. That's probably how they made it make sense to themselves, and that's good. That was way better than all the other craziness I saw all over the papers. So, you know, that's kind of how you have to get your mind wrapped around it. That works. But I'm going to show you one other thing. I want you to, right here, I want you to write a lowercase cursive h. No, I'm sorry, a lowercase cursive, a lowercase cursive h, like this. Okay, so very similar to that, even if that's how you wouldn't normally write it. Now, I want you to turn your paper upside down. And what is it? A Y, okay? Because I really meant to tell you to do a lowercase cursive y, but it really doesn't matter because it's the upside down, right? So turn it back around. So Y, oh, I should have done it like that. Because if you do it like that, it doesn't look like an H. But a Y, like this, when you rotate it around, looks like H for horizontal. All right? So Y equals lines are horizontal because a Y rotated around makes an H. Y goes with horizontal. Make sense? Maybe you need that, maybe you don't, because you already don't get them mixed up ever, but most of you do. So if I do X, if you rotate that upside down, what do you get? An X. So it was not quite as exciting, right? So, but if you split it in half there, you get vertical. So That's where your vertex is. This is all 100% review. You cannot afford to mess any of this up ever again. You cannot afford to have to waste more than 2 seconds to think through any of this ever again, because this is just going to be small parts of bigger things that we do. If we take something and we're going to revolve it around the line y equals 5, and you can't even graph the line y equals 5, you can't do any of the problem, even if you understand everything else that goes with it, because your line isn't even right, so everything is 100% wrong. So these things here are going to come up a lot. Do whatever you got to do with any of these tricks to make sure that you remember them and know how to do it. Okay? Does that make sense? We good? Awesome. All right, so you can click. All right, so this is page 47. All right, so we're just going to run through slope. Okay? First of all, the word ratio. Who can describe to me what a ratio of something is? What does that even mean? It's like a relationship, and it's like a fraction. It's the comparison of two things and their relationship. Mathematically, when you see the word ratio, you should automatically think fraction. Okay? It could be done with a colon, it could be just some other things, but fraction is what should pop into your head, so you know you're going to make up a fraction of some sort, or you should have a fraction or something like that. Okay, so there's magic words when you go and you're graphing and you're using your slope and you're counting. It's the what to what. What over what? Okay. It's hard for me to ask this question without giving it away. Is it x to y? Or is it y to x? Because when this is written out like this is the numerator, this is the denominator. What goes in the numerator of slope? Y. And the words that go with it are what? They both start with an R. Rise over run, that's what I was looking for. And the rise is your y, and your run is your x. It's probably the first thing that you had where y came first, because x always comes first. X is always first. But y is first. It's in the numerator because it's rise to run. That's how you can make sure that you understand that. So the actual slope of this line, or of a line using these 2 points right here, it is a ratio, so it is a fraction. And you were looking for the difference in the two. Yeah, it's the change, right? So this is just going to be y2 minus y1 over x2 minus x1. That's something that you should know without a doubt, without a formula chart. Okay? We all good? All right. So down here. Not that far down. All right, so that right there is the slope formula. That's what's going to be on your formula charts. That shouldn't be the only way that you actually looked at it in Algebra 1. Okay, so I don't want anybody to say anything when I write this down. I just want you to write it down and keep your mouths shut. All right, so write this down. Now, I want you to raise your hand if you have never before in your life seen that. It's going to make me cry, probably. Okay. So this, if you were in a pre-AP Algebra 1 class, this should have been how you were talking about slope. This is the big boy and girl way to talk about slope. Okay? It's something that you absolutely have to be familiar with and understand. Now, where are my 10th graders at? All right, so can you tell me, because so far in chemistry, you may or may not have gotten this far, I don't know. But can you tell me what this little triangle is? Because it's not triangle. But what is it? Not what does it mean, what is it? Like, what is this thing right here? Because I could put that anywhere, and it doesn't. It's a Greek letter. Which one is it? Anybody tell me that? All right, the way you say this, what this is the Greek letter delta. It looks like a triangle, okay? So this is, and in quotes, and y'all need to stop answering questions on your test in quotes, because what you're doing makes absolutely no sense. Why do I put things in quotes in our notes? Why, what does it mean when it's in quotes? It's how you say it, right? If how you say it and how you write it are two different things, that's why I'm putting it there. So when you put quotes around things on your homework, on your test, that makes absolutely no sense. You clearly don't know what you're doing. So this is, what comes out of your mouth is delta y over delta x. Okay, delta y over delta x. That's what that is. That's the Greek letter delta. Delta y over delta x. Okay, now, Alyssa, what does delta mean? The change. And you learned that in algebra or in chemistry? Both, okay? And so delta means change regardless of whether or not you're in algebra or chemistry or physics or calculus. It doesn't matter. Just like pi represents that irrational number that it represents, no matter what course you're in, no matter what city you live in and what country you live in, delta represents the change. So this is the change in y over the change in x. That's what it means. And when you subtract two things and get the difference, isn't what you're looking for is the change? What's the difference between the two? That's all that really is. So this is how we should write it, and you need to know what it means and how to put the stuff in, okay? Delta y over delta x. Now, slope. There's a three-word phrase that goes with slope, and you've got to know that they're tied together. If I haven't told y'all this already, we have an AP lead for the district, and she's the AP calculus teacher at Pasadena. And she's coming over to meet with our calculus teacher once a week. But the pre-cal teachers asked if we could meet with her as well so that we could just like sit and listen and make sure that we were on the right track for preparing y'all for the journey and all that kind of stuff. And so there's things that she says that she's like, well, look, this is what they're still struggling with. This is what they're still struggling with. And I can tell you, it's not just about bumping it down to pre-cal and making sure it's all the way to here and below. Because slope is one thing, but that's not what we call it anymore. And just in case you didn't understand this, calculus is not that hard, right, Shiv? I can be a calculus student. I'm going to put you on the spot, all right? The calculus concepts themselves, like just the pure calculus, is it really that crazy hard to understand? What kicks your butt the most within all that? Is it the algebra y'all get lost in more than anything? Or that makes it more complicated? Yeah. Are kids in your class, maybe not you, maybe yours is perfect, I don't know, but are people making more algebraic mistakes or calculus mistakes? There you go. Okay, so if you don't believe me when I say, and I didn't even tell him, I didn't pay him to say that or anything like that, all right? I can tell you that Algebra 1 is the most important math class you'll ever take, all right? I have more college hours of math than y'all could even imagine exists, and I would still say that. Because if you don't have that solid foundation, you're going to get into calculus, you're going to understand the calculus, you're not going to be able to work the problem. That's happening to some of you in here right now. You understand the geometry, you can set it up, but then past that, it's just a hot mess, all right? So there's also things that you have to tie together. Okay, slope, every time you see a set of three words, can anybody tell me what it is? What is it? Rate of change. Thank you, Molly. Okay, so slope is, and I want you to write this as big as you have room for, rate of change. Just like when you see ratio, you should think fraction. There's other ways to write ratios, but mathematically that's most likely what we want. Anytime you see rate of change, all you're doing is finding the slope. That's it. Okay? I'm not saying you'll never use the slope formula again, because it's still what you're doing. You'll still think about things that way, but you need to understand what delta y over delta x means. Okay? We all good with that? Questions? All right. Next page. So it says determine the slope of the line if A is this point and B is this point. All right, so we're going to just do a ballpark graphing again. All right. So if I'm going to go to 8, -3, that looks good. There's A. B would be at -4, -12. Like, that looks good, right? Something like that. So here's my line. Now, we're not counting anything because there's nothing to count because I didn't make any hash marks. All that's a big fat waste of time. But what can you tell me about the slope just based on what we did right here? It's positive. Remember, poor me if we're going uphill. Okay, so I know it's positive because one of the mistakes I know y'all make early on in slope is that you get maybe you get it in the numerator and denominator right, but then your sign's wrong. Well, you know that it's supposed to be positive. So in the end, if you don't get something positive, you need to go find your mistake. But also in the end, just because you got something positive doesn't necessarily mean you're right. So, I mean, it's not 100% foolproof here. So we're looking for the slope. The slope is delta y over delta x. That is the change in y over the change in x. So I'll look at my y's first. -12, -3. So that's -12 minus a -3 over -4 minus 8. So what is -12 minus a -3? -9. over what? Negative 12. Okay, so what happens to the negative over negative? They cancel out, becomes positive, so that's good. So is my answer 9/12? No, because you always have to reduce it. What do you get? 3/4. Good. So 3/4 is the slope. Okay. Everybody okay with that? All right, so the next part of this, it's another one of those things that was in algebra, out of algebra, in algebra, out of algebra. In algebra if you had time, but not everybody did it. And so I don't really even know at this point. I get confused when it goes back and forth so much. So this may be a review to you. It may not, but my guess is even if it's a review, you probably didn't hear it 100% like this. All right, so we've got parallel lines. So we know that parallel lines, can we just say parallel lines are two lines that never cross? No, they have to be what? Two coplanar lines that never intersect, right? All right, so this is not necessarily the definition of parallel, it's just what happens with their slopes. So in a coordinate plane, two non-vertical, okay, non-vertical, so the vertical ones don't count. Two non-vertical lines are parallel if and only if they have the same what? Anybody know? What has to be true about the two parallel lines? What? Slope. They have to have the same slope. But what has to be different about them? The y-intercept. Very good. They have to have the same slope but different y-intercept. Because if they have the same y-intercept and the same slope, it's just the same line. So that's why they never intersect, right? Because they have the same slope. So if the slope changes, that's going to make them intersect. Right? But it says two non-vertical. Well, can two non-vertical lines be parallel? I'm sorry, can two vertical lines be parallel? Yes. All right. So why do you think this doesn't include them? Because it's undefined. Do these lines have a slope? No. Vertical lines don't have a slope. So it doesn't fit into this. I can't say they have the same slope because they don't have a slope, right? Do the horizontal lines have a slope? What is their slope? 0. These don't even have one at all. This at least gets a 0, right? This is just undefined. So we have to add to that and say that any two vertical lines are parallel. So that has to kind of have its own statement since it doesn't fit into the box of the other stuff. It doesn't fit the definition or the rule. All right, so then it goes on to say, in a coordinate plane, two, again, non-vertical lines are perpendicular if and only if the product, what does product mean? You do? Multiply. Product is the result of multiplication, right? The product of their slopes is blank. Okay? So my guess is, can anybody tell me what they know, even if you don't think it's going to fit in this blank? What do you know about the slopes of perpendicular lines? What? Now I want you to guess. I want to know if you've been taught it. Yes. Okay. They're opposite. Does that sound familiar? Okay. The word opposite, very dangerous. Okay. That may have been what you've were told. That may have been what's in your head, and that's okay that you said that because it's probably how you've understood it. But opposite can mean a lot of things. All right. So really, tell me what you mean. Can you tell me what you mean by opposite? Okay. So let me just give you this. If I had 2/3, what would the slope of the line perpendicular to it? Can you tell me that? -3/2. Okay. Okay. Is it just the reciprocal? Negative reciprocal, right? Okay, so that's what we're going to put right here in this little star because that's not really what goes in that blank. These are negative reciprocals. So that is a beautiful example of knowing what to do, totally understanding the concept, but not being able to give me the words. That can be a big problem for you. All right, you've got to be able to say what you mean and say what you understand. And I understand that is not something that you are necessarily focused on a lot. That's one of the things I'm trying to help you with. Okay, but do we all agree that those two slopes there would be the slopes of two perpendicular lines? Yes? Okay, so then it says two non-vertical lines are perpendicular if and only if the product, which means we multiply, of their slopes is blank. All right, so what's the product of their slopes? -1, right? This is going to give me negative 6 over 6, which is negative 1. So the product of their slopes is negative 1. Because what if I told you that the slope is 0.38726593? You're going to be able to find the opposite of that? What the heck does that even mean, right? Because opposite, some of y'all try and subtract that from 1 or something. So we got to make sure that we understand that it's the negative reciprocal. Okay? That makes sense to you? Yes? No. The product of the slopes of two perpendicular lines is 1. This is the slope of one line. This is the slope of another line. Those two lines are perpendicular. So when you take the two slopes and you multiply them together, you get negative 1. Okay? That negative 1 has nothing to do with the actual slope of either one of them. Okay? All right, so then it goes on to say, blank lines are perpendicular. All right, so again, we had to say two non-vertical. If I have a vertical line, what's perpendicular to a vertical line? A horizontal line. Is the product of their slopes negative 1? No, because this one's 0, right? And anything times 0 is 0, but this isn't even anything, right? I don't even have anything to multiply by the 0, right? So I can't get that negative 1. This works for every line except for every set of lines besides these two. So we have to have a little separate thing about this too and say horizontal and vertical lines. Whoops. I don't have to set lines because it's already there. Horizontal and vertical lines are perpendicular. Okay, everybody okay with that? All right, so raise your hand if you learned that stuff last year. I think not everybody. Okay. I'm pretty sure it's back in Algebra 1, but I wouldn't bet my life on it. Okay, so this says find the value of y that satisfies the given conditions. The line containing negative 4, 9, and 4, 3 is parallel to the line containing negative 8, 1, and 4, y. Okay, great. I didn't know that I asked the question, but all right. So this says we got these two lines right here. If it says parallel, what does that tell you about the slopes? They're equal to each other, right? Their slopes are the same. So slopes are equal. So if we know that, then we need to go and find the slopes, right? So I'm going to start by finding this slope right here with these first 2 points. So the slope is delta y over delta x. So this is going to give me 3 minus 9 over 4 minus a negative 4. What's 3 minus 9? Negative 6 over what? 8. Okay. What does that reduce to? 3/4, negative 3/4. If you want credit, yes. Every time. Every time. All right, so there's your first one. By itself, it doesn't really mean anything. So then we have this. Looking for the slope. It is delta y over delta x. So this y value is y minus 1 over 4 minus a negative 8. You shouldn't even hesitate on something like that. You don't know what y is. Who cares? You have 2 points. You plug them in just like you would anything else, right? So then we simplify. Y minus 1 is just y minus 1. Can't do anything with it, right? What is 4 minus a negative 8? 12. Okay? So that's the best I can do on that second slope. Right? Now, I've got to figure out what y is. What do you think I could do here? Good. If the slopes are equal, I mean, sometimes y'all get stuck at this. You can tell me the slopes are equal, then set the slopes equal to each other, right? So I've got negative 3 over 4. That's equal to y minus 1 over 12. You have two ratios, right, that are set equal to each other. What is it called when you have two ratios that are equal to each other? What's the word that usually goes with ratio? Okay, yes, good job. It is fraction, but you usually hear ratio and something together. Starts with a P. Ratio and 3 syllables. What? Proportion? Ratio and proportion? or the word proportion. So the difference between a ratio and a proportion is a ratio is one fraction. A proportion is when you have two fractions set equal to each other. If you've got two fractions set equal to each other, I don't have anything extra on either side here, then I can solve this by cross multiplying. Right? So that doesn't mean you cross multiply and divide, because that's not showing any process. I'm going to multiply the negative 3 times the 12, right? And that's equal to 4 times y minus 1. Am I missing anything here? So does negative 36 equal 4y minus 1? I need the parentheses here. There are no parentheses here. Who cares? We need them here because I need 4 multiplied by that whole thing. And if you don't put them there, you're not going to have the right answer. So negative 36 equals 4y minus 4. Negative 32 equals 4y. Ooh, I left off my 4. 4y. So y equals what? Negative 8. All right, so what are we looking for? It says find the value of y. We have done that. Is there a way to check ourselves? Yeah, plug it back in. Negative 8 minus 1 is what? Negative 9. And negative 9 over 12, does that reduce to negative 3/4? It sure does. There's your answer. Okay. Any questions? We good? Awesome. All right. Next one. It says use the slope to determine whether the lines are parallel, perpendicular, or neither. So I've got these two lines here, UV and XY, and here's all this information. So we're going to have to start by finding the slopes of both of them. We'll start with line UV. Okay. So for UV, slope is delta y over delta x. Make sure you're using the correct 2 points since you got so much there. So this is going to be negative 1 minus 2 over negative 1 minus 0. So that's negative 3 over what? Negative 1, right? So what is negative 3 divided by negative 1? 3. Okay, so this one is 3, right? So then I've got to do xy as well. And for xy, slope is delta y over delta x. So I'm using these two here. This is going to give me 3 minus 1 over negative 3 minus 3. It's going to give me 2 over what? Negative 6. What does that reduce to? Negative 1/3. Okay, so are these parallel? No. Are they perpendicular? Yes. Okay, so then we need to write a statement that they are perpendicular. So now we have these. We need to say that UV is perpendicular to XY. Okay. So you can't just write perpendicular. You need to actually write out the statement of what we have. Okay. Everybody okay with that? So next one. We do the same thing. We'll just run through these together. We'll start with AB. Slope is delta y over delta x. Slope should be very simple to you. It should be something that you can do quickly and don't make mistakes in. 1 minus 2. So 5 minus 1, 1 minus 2. It's going to give me 4 over what? Negative 1. And so that gives me negative 4. Okay, so there's 1. Then I do CD. Slope is delta y over delta x. And that is going to be negative 2 minus 2 over 5 minus 4. So that gives me negative 4 over 1, which is negative 4. Okay. So are these parallel, perpendicular, or neither? Parallel. So we need to make the statement that says line AB is parallel to line CD. You need to actually make the statement there. Okay. Any questions about that? Good. All right. All right, so then here for UV, slope is delta y over delta x. is equal to 2 minus a negative 2 over 1 minus a negative 3. So what does that give me? 4 over 4, which is 1. For xy, slope is delta y over delta x. So that's going to give me negative 4 minus 4 over 2 minus a negative 2. So what do I get in the numerator? Negative 8 over 4. That reduces to negative 2. So if I was just thinking slopes are supposed to be opposite, well, they're opposite in some way, right? One of them is positive, one of them is negative. Is that enough to be parallel or perpendicular? No. So I'm trying to decide if they are parallel, perpendicular, or neither. So these are neither. Any questions about that? On your homework, when it asks you that, you need to show process for each slope. You need to have the slopes correct and a statement written out whether they are parallel, perpendicular, or neither.